Hello everyone, my name is Tim, and today we're going to talk about something really exciting. That's the pH chart, the pressure enthalpy chart. Before we get started, a couple of things you should know. You're going to need to start off with a good thermometer, some gauges. Now, as you can see in this particular case, I've got my condensing unit, my evaporator. They come in many shapes and sizes. The expansion devices come in many shapes and sizes as well. The coils come in many shapes and sizes. The compressors come in many configurations. Okay, we're not going to talk about those in this application. So, we're going to talk about the basic concept. When you get started, what you're going to want to do is get the right gauges. I recommend a digital set of gauges. Okay, this is a really nice set that allow you to not have batteries because they're solar powered. The better ones are something like this that allow you to get digital outputs. It actually converts internally pressure to temperature for those refrigerants, has clamp-ons, clamp-onto the line sets, so you can actually measure the temperature, superheat, subcoolings, all that kind of fun stuff. So, we're ready to get started. Here we go. So, the basic refrigeration circuit that we're going to be talking today doesn't include all the accessories. I'm just showing them because it looks cool. Now, the compressor, the job of the compressor is to compress. Its whole job is to raise the pressure high enough that the pressure, when converted to temperature, is higher than ambient. So, for example, if I had 80-degree ambient temperature, I would, no matter what, have to pressurize that to a pressure that equal the temperature higher than ambient temperature. And normally that's about 20 to 30 degrees higher than ambient, because the greater the delta T, the faster it's going to move that heat. So I come through the compressor, superheated gas, because this will not pump liquid, it's that gas vapor compressor. Go into the condenser, do desuperheating, then I go saturated, and then I go subcooled, which we'll explain in a little bit. Come up through the liquid line, through the expansion device, where we have the adiabatic process take place, where I get a drop in pressure without a drop in physical temperature or enthalpy. Comes down, picks up heat from the evaporator, picking up heat, comes through, and back to the compressor. Now our key words are saturation, which means I'm in both liquid and gas. Superheat, where I take the saturation and raise it 1 degree. No longer is it a gas and a liquid mixture, it's now all gas. Subcool, I take that saturated liquid and gas, cool it down 1 more degree, and now I've got subcooled, 1 degree of subcooling. So I take saturation, raise it 1 degree, I have superheated gas. If I raise it 10 degrees, I have 10 degrees of superheated gas, 10 degrees above saturation. If I have 10 degrees of subcooling, I have 10 degrees below. Submarine, think submarine. Diving, I'm colder than saturation. Super, think of Superman, people flying. I wish I could fly. Now, that means above the saturation point. Adiabatic, that's where I get a change in pressure, but I don't get any enthalpy change. Total heat content. Absolute pressure. I take my gauges that I showed you earlier. Those are they read in PSIG. I add absolute pressure, which, for example, if I was at atmospheric pressure of 14.7 at sea level, I would add, and I had 100 pounds on my gauge, I'd add 14.7, or I'd have 114.7 PSI A. So let's take a look. This is what we're talking about today. These are the scenarios that we have for both temperatures and pressures. Okay? So, take a look at this, walk through it, and I'm going to walk through the next slide. This is my pressure enthalpy chart. If I look at these numbers right here, this is quantity of gas compared to liquid. As I go this way, for example, I'm at 90% gas. I'm going less and less gas and more liquid until I get to here, where I'm at 90% liquid and 10% gas. When I pass this saturated line right here, I am now subcooled, submarine. Okay, I'm in the subcooled region. As I enter, I'm going into here. This is the superheated line, or the saturated vapor line. If I pass this, there's some liquid there. Before here, it's all gas, superheated gas, okay? Also, I have some temperature lines here that I can use for plotting. These are and used for plotting where I'm going to start my chart, my line. Now, in a typical diagram, we have the compressor. We're going to start the compressor right here. My compressor in my application started at about 150 degrees. So I find 150 degrees here. And then I go, my pressure was about 385 psig right here. So I plot from 385. I'm now going through, starting through the condenser. It's removing heat, removing heat. So as soon as I leave that compressor, it's removing heat. Yes, there's some heat that gets exchanged as it's through the piping, but we're negating that right now. I'm entering the condenser, removing heat, and I'm desuperheating. Magic! Suddenly, I now turn into saturation, and those PT charts that I have will now work. And there's apps for that. You can see them on my site, mucky.com. Click on Tech Services, all kinds of fun stuff there. Okay? As I go through that condenser, the pressure is going to drop a little bit because it's piping, and the compressor is sucking on that line, so it's going to drop the pressure. So if you look, as I'm going through here, the average pressure in here is going to be about 365 pounds. So 365 pounds, or approximately about 110 degrees for the 410A. So the pressure's dropping a little bit, almost insignificant. So when I go into this liquid line, the pressure might drop down to maybe 355. At 355, that gives me right here where I got my subcooling of about 10 degrees. And again, subcooling, you cannot do a direct relationship between pressure and temperature. But we know that we got some sort of pressure drop because it's going to a line. It's got to have a pressure drop. It can't be a constant pressure because there's pressure drops through this whole thing. But we're saying it's relatively insignificant. Now I go through this expansion device right here. Now I get that adiabatic process where, if you look, before when I was coming through that condenser, I was dropping in enthalpy, dropping in the total energy content. But as I drop in pressure, the enthalpy doesn't change. So the adiabatic process, it actually cools by dropping the physical pressure without changing the enthalpy. I'm physically changing the temperature. And it's dropping on these temperature lines. See the temperature lines? It's dropping on those temperature lines. So it's dropping the temperature without a change in enthalpy. That's the adiabatic process. As that leaves that expansion valve and enters the evaporator, I'm now going to start picking up heat. I'm picking up heat this way. Picking up heat. It's sucking that heat out of that room, out of that refrigerator, and getting ready to throw it back outside. Picking up more and more heat, and you can see how much energy it's picking up per pound on that refrigerant as we go this way. As I pass this saturated curve, vapor curve line here, now what's happening is I can no longer use my pressure temperature charts. I am now picking up additionally above saturation. I am now Superman. I am now going above the saturation line. Over here, I was going below the saturation line, which means I was subcooling. But now I'm superheating it because my poor little compressor here will not take a liquid. If I get liquid in there, the compression ratio goes through the roof, things break, and makes me very unpopular, okay, with my customer. Now, it enters the compressor. In the compressor, it's picking up some heat. We can figure out exactly how much heat it's picking up here. But in my case, I'm coming in here at about 47 degrees. I got about 10 degrees, 12 degrees of superheat here, and about 10 degrees of subcooling here. So I pick up a little bit of heat just to make sure that it stays a gas, go into the compressor. You can see I'm raising the pressure, raising the temperature, and I start the process all over again. So, that is the pH chart. I want to thank you very much for participating in this little discussion. Please feel free to review this at your leisure and my other videos as well. This is Tim.